Oh, the one that I did.
Yes. What was Mexico too? You had a triangle, right?
Oh, we have here.
Wait, you took my solution, right?
Yeah.
Oh yeah, the angle chase.
The massive 20-step angle chase.
Hey, I have one that's not massive.
Yeah. So I'm basically presenting. I think mine and Sean's solution are pretty similar.
Okay. We can't bash this one too.
There's a lot of circles, I think.
There's too many circles.
Okay, so you have an incenter and BI. I can't remember which way I went. Oh, I went this way. I must have gone this way. Alright.
Let me go grab my solution.
Let me go get my solution.
I think I went this way. Oh no, this is CI. Yeah, so BI goes there, right? This is CI.
Oh. What? Why is this one taped? Wait. Stop it.
Oh, I remember now. So this is the incenter, right?
Snake.
And this is like P.
Yeah.
Yeah. And then we have E. What's E? E is
See if I can figure out how my solution
the second point of intersection and circle ABD. A, B. Okay, what's D? That's this is D.
Where's my book?
Diagram dependency, different orientation.
Okay, so then you have E is somewhere on this circle. A, B, D, yeah?
Yes. My
No, this is
hobby
my
is
five
angle
diagrams.
chase.
No, where's my good
I
diagram?
have way too many angles.
Where's my good diagram?
So it's
E.
all the way around. I don't know how to do this.
That just looks freakishly collinear.
Oh yeah, I think this was the instant.
Q is the second intersection of EP and the circumcircle AEC.
Wait, I think I did. Yeah, I remember you were...
EP
Space. Oh, it's good.
with AEC.
Is it just pure anything? Yeah. I forgot. Why do you have so few? I have like 10 quadrillion angles on my diagram. I just wrote on every angle. What the?
I just did coloring.
You guys are scamming me.
2 red plus green.
Okay, so it's a bit annoying that AIE looks too collinear.
Yeah, like
but
that
it's
was my
not.
diagram.
Diagram this time. Wait,
Who was doing this before? Like,
wait,
Yeah,
what?
that was me. That was me.
That was you.
Science diagram. Or you could just draw another diagram.
Yeah,
Yeah.
Oh.
diagram.
Wait, just
Diagrams
just
aren't
move
growing
the
on
eye.
trees, you know.
Just move the eye somewhere.
No, but that's
somewhere else.
no, but they do.
Move E somewhere else.
Move E somewhere else.
Yeah.
Yeah.
No, but then you mess up P and Q. Oh.
Yeah, okay, just leave it for now. Okay?
She'll be right.
Okay. So what are we trying to do? We're trying to prove
Start with, I think.
PDQ is 90.
Oh,
Yeah, okay, so it makes sense to kind of draw in this.
PDQ. Oh, it actually looks.
Oh, look at Michael's diagram. QDPC looks cyclic. Whoa, so it must be cyclic. It must be cyclic.
Oh.
Wait, is it?
It is though.
Wait, is
That's
it?
the whole
Oh
thing.
yeah.
That's what we spent the whole time doing. Proving cyclicity.
Why is it cyclic? Well,
Long story.
Yeah, it's a long story. About
Angle.
20 steps of angle chase later. Yay.
Okay,
I
so
love how
basically,
question 2.
Oh, I think this is out.
Oh, question 2 is natural.
Oh yeah, actually yeah. Oh, it's 6 questions, so 3.
1, 2, 3.
I don't know.
okay, so let me kind of summarize what's happened, yeah?
I'm gonna do it again.
So we drew in this line. So the red lines are kind of lines that weren't originally in there, yeah?
Yeah.
And we went, well, so my process was, this looks like an angle bash.
Wow.
Okay, so I just angle bashed.
Wow.
And
What's the angle chase?
I found out that basically I could label every single angle in this whole picture except for like the one I needed here. Yeah.
Oh, that's alright. So we have two
Okay.
inside and that's fine.
Bruh.
Yeah.
That's all good.
But and I also made some mistakes labeling some angles. But
We all do.
but the thing that didn't get mistaken that was kind of interesting was that this was an angle bisector of E.
Yeah.
Yeah. So how do we show that?
Because.
Case.
Okay.
Oh, already bored already.
So angle BFI.
Okay, just name all the angles.
B, D, yes.
Get all the colours. Get colours.
Wait, extend CI.
C,
Extend
I.
CI.
I think that's
No,
how.
no,
I
no.
did connect AQ. I think.
A, Q.
What?
Second
What?
chord. Wasn't it DECQ?
No, this.
Wait,
No,
wait, not DECQ.
I think
Does
we
anyone
can
have a
do it.
phone? My diagram is fine.
Yeah, DECQ cyclic, I think. Wait, what is cyclic?
The diagram
It's
probably
wrong.
not.
Diagram.
Oh, it's the wrong one.
Yeah, so I guess this angle here, right? This angle here is just A, right?
Yeah.
Is that right?
Yeah, I think so. Because ABD is cyclic? Yeah, it is. Wait. Yeah.
Yeah, ABD is like yeah.
What do you do?
So we got to find one of these angles.
Oh, what did I do? I chased it around.
I knew I should have shown this yesterday.
I showed that the other angle is bisected.
Oh, the B.
Yeah. The B.
Yeah, I mean we know this angle's bisected already, right? So it suffices to show the other one's bisected.
Wait, which one of the others was like? What?
So I extended
It's
CI.
A B D E. Yeah,
Sorry? Wait, is
That
that
sounded
what we
pretty
know or
satisfying.
what we're trying to get?
that's what we know.
Oh, very sad.
So I extended CI and then like you chase some angle. And stuff comes out.
I chased angles around like AQC. Like that triangle. And QEC.
Because once I extend
alpha minus
CI, you get that like C.
Or maybe I can join
I
this
have no idea
separately.
how this is.
So I join this. It's not collinear, okay?
What?
AD.
Isn't that
AD
collinear?
is
Oh wait, I didn't know
same
how
as
to do
half.
it. Okay, I'll just make a new proof as I go. Let's angle ABD equals angle BBC.
So this is like beta. Beta. This is beta, right?
Yeah.
BC equals beta.
Wait. Let's get my orientation. That's what's really
Oh, so these are isosceles.
DPC is similar to triangle.
Okay, wait. What do we do?
Oh, we're trying to show one of the angles is bisected.
Yeah, so I extended CI.
You extend CI.
Yeah, you call that point where it meets ABF.
F.
Yeah, and then CFB is like 2 alpha plus gamma
CFB is
from
2
exterior angle.
Yeah.
So then the other FIB, not F, yeah, FIB is like 90 minus alpha. Or it's like gamma plus beta. Yeah, and then you bring it over to the DIP.
DIP. Yes. Okay. Oh, okay. 90 minus alpha. Yep. 90 minus alpha here. Yeah.
Yeah.
And then that angle becomes.
Because put 90 plus alpha on DPC.
DPC.
Or like CCDP just becomes beta now.
Oh, okay. So this is beta here, right?
Yeah.
Yeah. You see that, people?
What happens?
So 90 minus alpha, exterior angle with gamma, so that's beta. Yeah.
Yeah.
And we just have to show that's beta as well.
No, but it is from exterior.
Oh yeah, because it's the exterior angle here. Yeah.
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 So then the point is P is the incenter of CDE, right?
Oh, I do that as well.
Oh.
Yeah?
Yeah.
Okay. So now, like the thing is, you don't need to know the incenter excenter lemma, right? Because Leo didn't know it, and he did it.
Yeah.
But actually, he should have known it because it was.
I didn't know if I didn't use it.
Yeah, I knew it, but I didn't.
chose not to use it.
I didn't feel the need to use it.
We don't need to use it, but knowing it actually helps. Your so because the thing is, you know, you kind of made progress when you get a bunch of angles, right? But you still haven't solved the problem, yeah? But if you know the incenter excenter lemma, then you know you've solved the problem at this point.
Oh wait, who's the excenter?
Q is the excenter, right?
What?
Because that's what the whole point of the incenter excenter lemma, right? Is that CPDQ is cyclic, with QP being the diameter, right? That's the incenter excenter.
Yeah, but how do you know it's the... So you know P, you've proven P is the incenter, but how does that make Q the excenter?
Well, it has to be, right, for it to be true.
For the question to work.
So you have several ways of proving it now, right?
Oh. But how?
You could use the lemma directly if you had no other choice, right? You could actually just write the lemma, prove it. Well, what?
How would you do that? Yeah, how would you use the lemma?
You could just reverse reconstruct. So the lemma says it has to. These three are cyclic, right? With that 9 degrees. There's only.
The lemma? I thought the lemma was like Q's equidistant from DP and C.
Oh, that's a different one.
Q's equidistant from DP and C.
The one we learned, like.
I guess it's...
So like the lemma is like this. So if you have a circle, right, with an angle bisector, yeah.
Yeah.
This point M is the center of the circle.
Oh yeah, that's the one he's holding. Yeah, and then you
with B, C,
and I.
the incenter,
Also E.
and the excenter, yeah.
Yeah. You extend.
And it's 9 degrees, yeah.
Yeah.
Oh, can you tell us what the 9 degrees?
Yeah, but 9 degrees is obvious.
Is it?
Because M is the
Is it
center.
trivial?
Oh yeah.
It is trivial.
Because it bisects the 180 altogether, right? It's bisector. The bisector goes to here and here.
Wait, what?
So the angle bisector goes to I, right?
Yeah.
The external angle bisector goes to A, yeah.
Yeah.
But the internal angle plus the external angle is 180.
Yeah.
So that has to be 90 when it's bisected. Yeah.
So, okay. How do you prove that one?
Oh, so you can prove it by more angle change, but actually you're kind of sort of proving it again anyway. But you might also have some extra information.
I don't guess this is alpha. What?
Wait, don't you have to prove that like CPDQ is cyclic?
CP.
Oh, it is because like angle DBE is equal to angle DAE.
I mean, the cyclic thing follows from just them being 9 degrees in the first place. Yeah.
Well, if you prove it cyclic, you still get that sign. Yes.
Yeah, but the 90 degrees is the most obvious out of all of them. Yeah.
Okay.
Okay. Yeah, there's lots of ways to get that it's 90 degrees as well. Wait, we're also told. Yeah, we're actually also told that what like QCAE is cyclic, right?
Yeah.
So like this angle here which is alpha, right? Yeah?
Yeah.
So alpha plus beta is equal to this angle here, right?
Wait, that angle was alpha because.
Yes.
Yes.
That angle's alpha because it's angle bisector.
Oh,
And then the other one's also alpha plus beta because angles on a straight line.
Yeah, so alpha plus beta plus gamma is 90, right?
yeah.
So then you already know this is going to 90, yeah? So then you know Q is the excenter, and it comes back here at 90.
Maybe that's how I do it. Yeah,
But that doesn't use the lemma, right?
No, but like not using the lemma is kind of just a technicality, right?
Yeah.
Like
the lemma's only a few lines anyway.
it's like if your purpose for doing this question is because of the lemma, but you never mention it, it doesn't mean it wasn't there, right? It's like
You failed.
yeah, it's like an abstract. It's on a level more abstract than the solution, yeah. You know, it's what gives you the confidence to solve this problem from here, and yet you never used it at all, right? Well, for me anyway.
Yeah.
So that means this is 90 degrees.
I
It's a
did
big
it.
right angle.
Yeah.
Oh, there's no such.
Yeah, and so then you know that the excenter lies on the angle bisector
I don't know if this is alpha.
at 90 degrees to this angle bisector. Okay. Right, you need some explanation of this. So if you have like a triangle, yeah,
Did you get ICT?
the angle bisector is like that. Make the angles equal. Yeah. The incenter is the intersection of the angle bisectors. So there's an angle bisector here.
But it's CQ.
So incenter's here, right?
Wait, how we?
Okay. The excenter
Question.
Yeah.
is you take the angle
I don't use
bisectors on the outside of the angles.
Yep.
So it's like this one.
Yeah.
And this one, so let's call this one like
But it's
x, yeah?
yeah.
So can you see that circle plus x has to be 90? Because 2 circle plus 2x is a straight line.
Wait, which circles?
So
Alright.
circle
Circle
plus
meaning
x
that-
is a straight line, right?
Yeah.
So that's 180, right?
Yeah.
So half of it is 90.
Yeah, right.
So then that's 90, right? So that's why you know the excenter lies on this
Okay.
line with 9 degrees. See?
Oh yeah.
Yeah, but the question doesn't need you to know this is the incenter, that's the excenter. It just asks you to prove that's 90 degrees, right?
Oh, yeah.
But can you see how knowing it might actually help you without sort of even appearing in the solution?
Yeah, I guess.
Guess. Seems legit.
Seems legit.
It'll take time for everyone.
Why did my angle
Daniel's
say
here, he
what?
said he solved it too.
Which two?
Mexico
This
two.
too.
Oh, this.
He solved it too.
It's number two.
M2.
Okay, so we're all happy with that?
Yeah.
Very happy.
Yeah, so this is basically the same. This is kind of like what I know of Sean's solution and my solution.
Obvious.
Yeah, and even though there's lots of angles labeled, angle bashing had more angles labeled. I think I literally labeled every single angle except for the ones we needed.
Yeah, I labeled every single angle. Basically. And I drew lots of extra lines as well. So
Yeah, and there's a whole bunch of like similar switches in here. You see, because
similar switch.
Wait, are they not similarly?
oh, actually no, I just made some mistakes. That's all.
Bruh.
Bruh.
All right.